You know those 90s disaster movies? The ones with asteroids hurtling toward Earth?
Oh yeah, Armageddon, Deep Impact.
Exactly. Well, it turns out those movies tapped into a very real fear.
Mm,
Back then, the risk of a surprise asteroid impact was, well, kind of terrifying.
it really was.
This deep dive is all about how that risk has changed since then.
Okay, cool.
We'll be using Kardic's 2019 article in The Futurist, plus a follow-up video he did in 2021.
Sounds good.
You ready to get into it?
Let's go.
All right. So, first things first. Back in the 90s, why were scientists so worried about asteroids sneaking up on us?
Well, the technology back then was nowhere near what it is today.
Can you elaborate on that a bit?
Imagine trying to spot something like really small and dark hurtling through space. It's like finding a needle in a haystack in the dark.
Right.
Our telescopes just weren't powerful enough to reliably detect those potentially dangerous asteroids.
And Kardik has this great analogy about video games
Yo, yeah.
that helps explain just how much things have changed.
Right. Think about how much more realistic video games look now compared to, say, 20 years ago.
Oh, absolutely. It's insane.
That's because of the insane increase in computing power. And it's that same computing power that's revolutionized our telescopes.
So telescopes are basically like giant space cameras.
Pretty much, yeah.
Okay. And all that advancement has led to some pretty amazing results. Speaking of which, we have this incredible chart from JPL, the Near-Earth Object Detection Chart.
Mm-hmm.
This visual really drives home Kartik's point. It shows how many asteroids we found over time, and it breaks them down by size.
Okay.
The really cool thing is the line for the biggest, most dangerous asteroids, those over 1 kilometer, has basically flattened out. What does that tell us?
It means we've likely found most, if not all, of the planet-killer asteroids.
So we don't have to worry about those as much anymore.
Not as much, no. It's very reassuring.
Right. Like, phew, what a relief. But what about the smaller asteroids? I mean, even those can still do some serious damage.
Oh, absolutely. You're talking about the orange zone asteroids.
Right, the orange zone.
Those are the ones between 140 meters and 1 kilometer.
And those could, what, like wipe out a city?
Yeah, a city, maybe even a small country, but not like end all life on Earth.
Okay. Still not great, though.
Definitely not ideal.
Now, Kartik had some really interesting thoughts about the detection rate of these mid-sized asteroids. What did you make of that?
Well, the rate at which we're finding these orange zone asteroids is starting to level off.
Oh, interesting.
Which that probably means we're getting close to finding all of them.
So potentially, no more surprises in that size range.
Hopefully not. At least not as many.
That's good news. And it gives us more time to prepare, maybe even figure out how to deflect them.
Yeah, exactly.
Speaking of specific asteroids, you mentioned Apophis in your notes. Isn't that one we're keeping a close eye on?
Yeah, Apophis, it's supposed to pass pretty close to Earth in 2036.
Okay.
It's unlikely to hit us, but there's, a small chance.
I feel like Apophis gets a lot of attention,
It does.
but the odds of an actual impact are tiny.
Oh,
Gosh.
extremely tiny, yeah. Like winning the lottery, tiny.
Okay, so not losing sleep over Apophis.
No, I wouldn't.
What I find really fascinating is how the conversation around asteroids has shifted.
How so?
It's not all doom and gloom anymore.
That's true.
We're starting to see them as potential resources.
Yeah, like Kartik talks a lot about asteroid mining.
It's like science fiction coming to life.
Totally.
Yeah.
Instead of dodging asteroids, we could be mining them.
And not just for precious metals, but for things like hydrocarbons too, right?
Exactly. There are some that contain significant amounts of water ice and hydrocarbons, which could be really valuable, especially for space travel.
So we could have, like, space gas stations?
Yeah, imagine that. Refueling spacecraft without having to launch fuel from Earth.
Wow, that would be a game changer.
Yeah.
Okay, so we've talked about the risks, which are thankfully lower than they used to be.
Mm-hmm.
And we talked about the exciting possibilities of asteroid mining.
Mm-hmm.
But, like, what are the downsides?
Mm.
Could there be unintended consequences to all this?
Oh, definitely. We need to be really careful about how we go about this.
Like what kinds of things?
Well, there are environmental and ethical considerations. We have to figure out how to mine asteroids responsibly so we don't mess things up even worse.
And is there a risk of, like, a new space race with countries or corporations trying to claim these resources?
For sure. That's a big concern.
Wow.
We've seen how competition for resources can play out here on Earth, and it's not always pretty. We have to be smarter about this.
Absolutely. So many big questions. I think we need to give our listeners a minute to process everything.
Good idea. This is a lot to take in.
Let's pick up this conversation in part 2 of our deep dive. We'll explore the feasibility of asteroid mining, delve into those hydrocarbons found in space rocks, and tackle those ethical questions head on.
It's going to be a good one.
Definitely. You won't want to miss it.
So we were just talking about how asteroids could be this like incredible source of raw materials, but how would we actually go about mining them? I'm picturing these like giant drills in space and spaceships hauling back chunks of rock.
Yeah, that's a pretty cool image, but it's really a lot more complicated than that.
Yeah, a lot more complicated. There are a lot of different ideas being thrown around, but most of them involve using robotic miners.
Robotic miners.
Yeah, to
Right.
extract the resources right there in space.
Hmm.
Some people are even talking about capturing an asteroid and like processing it in orbit.
Wow, in orbit.
Mm-hmm.
That's a pretty wild concept.
It is.
It's like creating these off-world mining operations.
Yeah, exactly. Off-world mining operations.
And it's not just precious metals that we're after, right? You were talking about hydrocarbons before. The stuff we use for fuel here on Earth.
Right, so some asteroids have a lot of water ice and hydrocarbons, and those resources could be super valuable for space exploration.
Oh, I see what you mean.
Imagine being able to refuel your spacecraft in space
Right.
instead of having to haul everything up from Earth.
Hmm.
That would be huge.
Yeah. It sounds like we could be on the verge of like a whole new era of space travel.
Totally, yeah.
But I have to ask, are there downsides to all this? Could mining asteroids have some unintended consequences?
That's a really important question. I mean, we have to be careful about how we go about this. There are a lot of ethical and environmental implications that we can't just ignore.
Like, for example, could it create a new space race
Exactly, yeah.
with countries and corporations like scrambling to claim these resources?
Yeah, that's a very real concern.
Okay, so there's that. And what about the environmental impact? Could mining asteroids actually, like, disrupt the balance of our solar system?
That's another really good question. I mean, we've seen what can happen when we exploit resources without thinking about the long-term consequences here on Earth.
Yeah, that's true.
We definitely don't want to repeat those same mistakes in space. It really all comes down to responsible, sustainable practices.
Right. And, I mean, this reminds me of something that Kardec mentioned in his work that really stuck with me. He talked about extinction events.
Oh, yeah.
Yeah, specifically he talked about the asteroid that, wiped out the dinosaurs.
Yeah. I mean, it's pretty mind-blowing when you think about it.
Yeah.
Dinosaurs ruled the planet for millions of years,
Mhm.
and then poof, just like that, they're gone because of an asteroid.
It really makes you realize just how powerful those things can be.
And how important our work in asteroid detection and defense is.
Exactly. We definitely don't want to go the way of the dinosaurs. But thankfully, our ability to detect and track asteroids is getting much better.
Way better, yeah. Kartik actually compares the advancements in telescope technology to the exponential growth in computing power,
Oh, wow.
like Moore's law for telescopes.
That's a really cool way to think about it. So much progress in such a short time.
I know, it's amazing, right? We've gone from being afraid of asteroids to, seeing them as this potential source of resources, and, we're developing the technology to protect ourselves.
Yeah,
Pretty incredible.
it really is. And it makes you wonder about the future, right?
Right? Like, what's next?
Yeah.
What does all of this mean for humanity?
Exactly. That is the big question. And I think that's a conversation for our final segment. So join us for part 3 of this deep dive, where we'll really dig into those ethical and philosophical implications of asteroid mining, space exploration, and, our place in the cosmos.
I can't wait.
Welcome back to the deep dive.
Wait.
It's really amazing how we've gone from fearing asteroids as these destructive forces to now, actually considering mining them.
Yeah, no.
It's like a total shift in perspective.
It is. And I think it really speaks to how fast technology is changing and our understanding of space is evolving, too.
Totally. What was once pure science fiction is now becoming reality.
Yeah.
But this whole shift, it brings up some big questions, too.
It does, yeah.
If we start mining asteroids, what kind of impact is that going to have on humanity?
Right. And these aren't just theoretical questions. We actually need to be thinking about these ethical and economic dilemmas now before we're, too far down the road.
Right. For example, if asteroid mining actually takes off,
Mm-hmm.
who's going to benefit? Is it going to create a bigger gap between the rich and the poor?
Yeah, that's a valid concern. We've already seen that happen with resource extraction here on Earth,
Mhm.
So we need to make sure that the benefits of asteroid mining are actually shared fairly and that we don't repeat those same mistakes.
Right, exactly. And what about the environmental impact? Is there a way to mine asteroids sustainably, or are we just kind of trading one set of problems for another?
That's a question that a lot of scientists and engineers are actually working on right now.
Oh,
There's a lot of research going into, developing mining techniques that will be environmentally responsible.
okay. So there's hope.
Yeah, absolutely.
I guess it all comes down to being aware of those long-term consequences, right?
Yeah,
Both here on Earth and in space.
exactly. We need to move forward carefully, Make sure we're not creating more problems than we're solving.
Okay. So where do we go from here? Like, what's the takeaway for our listeners as we wrap up this deep dive?
I think the most important takeaway is that the future of space, space exploration and resource utilization is still like being written. It's
Yeah.
really up to us to decide what that future is going to look like.
Right.
We have this incredible opportunity to expand our horizons and push the boundaries of what's possible, but we also have a responsibility to do it ethically and sustainably.
It's kind of both exciting and daunting at the same time.
It really is.
Yeah.
But, as we wrap up here, I want to leave you with one final thought.
Okay.
You know, Kartik's work shows us that the more we learn about the universe, the more questions we have.
That's true.
This whole exploration of asteroids, it's just one small piece of this much larger puzzle.
Yeah. And that's what makes it so fascinating.
Right.
So, thanks for joining us on the deep dive. We hope this episode has given you a new perspective on asteroids and the future of space exploration.
We'll see you next time.